Hi, now I will be discussing on two-tailed hypothesis test, one-tailed hypothesis test in detail. Two-tailed hypothesis tests are also known as non-directional and two-sided tests because you can test for effects in both directions. When you perform a two-tailed test, you split the significance level percentage between both tails of the distribution. Say for example, I use an alpha of 5% and the distribution has two shaded regions of 2.5%. So which equals to 5%. How? Two-sided. Left side 2.5% and right side 2.5%, which becomes 5% what I have taken alpha. When a test statistic falls in either critical region, your sample data are sufficiently incompatible with the null hypothesis that you can reject it for the population. The generic null and alternative hypothesis in a two-tailed test, on the null hypothesis the effect equals to 0 and on the alternative hypothesis the effect does not equal to 0. The specifics of the hypothesis depend on the type of the test you perform because you might be assessing means, proportions or rates. Through the two-tailed hypothesis test, we can detect both positive and negative effects. Two-tailed tests are standard in scientific research where discovering any type of effect is usually of interest to researchers. This is all about the two-tailed hypothesis test. Now, I'll be discussing on one-tailed hypothesis test. One-tailed hypothesis tests are also known as directional and one-sided tests because you can test for effects in only one direction. When you perform a one-tailed test, the entire significance level percentage goes into the extreme end of one tail of the distribution. Either it may be a left or either it may be a right. As previously I have used an alpha of 5%, each distribution has one shaded region of 5%. So when you perform a one-tailed test, you must determine whether the critical region is in the left tail or in the right tail. So the test can detect any effect only in the direction that has the critical region. It has absolutely no capacity to detect an effect in the other direction. We have two options for the null and alternative hypothesis, which corresponds to where you place the critical region. So, the impact of this one-tailed test generally on the null hypothesis, the effect will be less than or equal to 0. And on alternative hypothesis, the effect will be greater than 0. One-tailed tests have more statistical power to detect an effect in one direction than a two-tailed test with the same design and significance level. One-tailed tests occur most frequently for studies like effect can exist in only one direction, effects in both directions, but the researchers only care about an effect in one direction. There is no drawback to failing to detect an effect in the other direction. So, it is not only, I don't say that only the advantages are there. The disadvantage of the one-tailed test is that it has no statistical power to detect an effect in the other direction. So this is all about the one-tailed hypothesis test and two-tailed hypothesis test with the advantages and disadvantages and the effect on null and alternative hypothesis. Hope you might have understood the concept. Thank you.